answers, but you have done it. You're fine. How did you find it, right?
Yeah.
All right. So, first question in the assessments. Level 1, 2, explain how the diagram. Now, a couple of people are a bit, shall we say, I would say the word lazy. I'm going to go with brief in their descriptions and explanations. So some of you definitely lost out because you were a little bit too short and didn't include all the details. So basically, this says, explain how the diagram can be used to prove Pythagoras' theorem. So the ideal answer is, Pythagoras' theorem states that the two small squares must add up to, or the area of the two small squares must add up to the area of the larger square. Yeah? So you can make that statement. In the diagram, you can see that the two small squares' area add up to the larger square, but that's not quite enough. How can I see that?
Oh,
Yeah?
because it gives like the triangles.
It does give the triangles. All right? I expect reference to the number of triangles. Right? Some of you just said, if you take the square of the... Well, do it then. But you didn't. Yeah? And the reason why this is a clever question is because you can't. This square is what by what?
4 by 4. Wait, no. 2 by 2.
2 by 2. This square is a?
2 by 2.
What's this square?
4 by 4.
No, it's diagonal.
Yes, exactly. This length here, on the triangle, or this length here, is this or this. It's not that diagonal. Yeah? This is definitely not a 4 by 4. Alright? Now, if we were to work it out, that would be a 4 and a 4, and this would be, therefore, 8, and the side length would therefore be the square root of 8. That's not 4. So in this question, there are no numbers, which is a bit like, it's a level 1, 2 question, so I'm being picky here, but if it was I could have made it a harder question by being really specific about, you can't say, oh, you just square it, because there are no numbers to square. And this question quite specifically says, how can this diagram, the diagram below, used to prove Pythagoras' theorem? So some of you, all you did was state Pythagoras. It's a squared plus, but that doesn't tell me how this diagram can be used. So I was looking for, if you add up the triangles in the small, all right, it's not 4, and it's not a 2 by 2, all right. How many triangles are there in this? Well, there's 1, 2, 3, so there's 8 in that one.
8 in that one.
There's 8 in that one, and there are
16
in that one. So this is, remember I banged on a lot about Pythagoras' theorem is the area of the squares. It's not the sides of the triangle, and that's because Pythagoras wrote down that the areas of the squares were related. That's how you can use it to find the triangle. So some of you, I've written comments about, well, I don't get, it just doesn't tell me. Does that make sense to anyone? Yeah. You see how you could have spent a little bit more time maybe on that one?
Yeah.
Okay. Are the following triangles similar? If they are, write down the similarity postulate used. So a lot of you figured out the postulate is just is it the three angles? Is it the angle side angle? Is it the side angle side? Which one are we going to use? Well, in this case, right, are the following triangles similar? And the answer is actually no. Okay, that's the answer. But, right, if they are, write down, well, we don't need to use the similarity postulate because there isn't one, but we do need to specifically state why. So lots of people gave me some good, clear, like, the best ones, the one, actually the one I liked most, was it yours? Someone wrote this, and they wrote, well, the first triangle is 2 to 3 to 4, okay, and the other triangle is the 5 to 6 to 8, and they are not equivalent. I don't think they wrote, but that's a very nice, easy way to answer that question. Yeah. Lots of people did write, well, 3 to 6, well, that's multiplied by 2. 4 to 8 is multiplied by 2. But 2 to 5 is multiplied by 2.5. So the best ones there was people listed those out. You know, so 6 divided by 3 is 2. 8 divided by 4 is 2, but 5 divided by 2 is 2.5. So you actually then have to be specific in saying the ratios are not the same. Okay, so that's what I'm looking for, that kind of answer. There's lots of, the ratio, I like that one. These are perfectly correct and I'm very happy with as well. All right, but that was basically, you have to be specific in why saying no. Clear? Any questions? No? Okay. Find the value of, I wrote these down, just use your calculators, just to check that you remember using the calculators. I haven't written the unrounded answers, but if you round correctly, the tan of 50 is 1.19. So the nearest 100 is the second decimal place. Okay. Sine of 56 is 0.83 rounded correctly, and cos of 34 is also 0.83 correctly. Okay. Do you all remember how to do that?
Yeah.
Just chuck it into your calculator. What do we have to be careful of in our calculator?
I don't know.
It's in degree mode, not in radian mode. Okay.
yeah.
Yeah. One person I think had some close but not quite answers, and I wondered whether, but they weren't in radians. I don't know what you did. All right. Have no idea.
They did it in their head.
Well, they would have been very good if they got as close as they did. All right. Any questions on those? Anyone like to go through how you got, if they got those? You know, not everyone got them right. Does anyone not know why? No? That's one to check. Okay. Tan of A is 5 over 4. How do we find A? Yeah, I think.
You do second function.
Yeah.
Tan.
So we do the inverse tan of 5 over 4, and we get the answer in this case.
51.3 degrees.
Yeah, if we round it correctly to the nearest tenth, which is the first decimal place. This is the inverse sine of 3 over 8 on your calculator, and you get 22.0 because we want it to the 10th. Yeah. And cos of A is 23.1 degrees. Okay, lots of correct answers there, I think, pretty much. Anyone not remember how to do the inverse sine? All good? Okay, find the size of the unknown sides. Basically, well, no, I'm not at the question I'm thinking of. This one, unknown side of a triangle, no angles. Yeah, a squared plus b squared is c squared. At least one person just took those numbers, and I think it's the next one, just always added. First thing we should do is identify that that's the c, and then we've got a b. Alright, so 15 squared plus 8 squared equals c squared. So is that 225 plus 64, and we square root it, and we get 6. So x. Okay.
17.
And you get 17. Exactly 17. Yeah, it's nice.
Yeah.
It makes you feel like it must be correct.
Yeah.
Sometimes they do give you questions where they know what the wrong answer, and that's also a whole number if you make the common mistake.
Like the math question.
This one definitely caught at least one person out.
C squared minus b
So
squared.
this is the C, this is the A or B, up to you. So we write it out as x squared plus 7 squared is 15 squared. Therefore x squared is 15 squared minus x squared. Sorry, 7 squared. Yeah. Therefore, I've got 225 minus 49 square rooted, and we get the answer
13.3.
13.27, blah, blah, blah. So I wrote that, so yeah. 13, it didn't ask you to round. If you put 13.27 or if you put the correct answer, that's fine. If you rounded, but you rounded incorrectly, let's say 13.2. I'm not saying that the whole question's then wrong, but I am saying that you've done something wrong. You don't lose all your credit because everything else is correct. Alright? So, did catch at least one person out.
Hot Latin.
Caught several people out on this one. Some people just made an assumption. Yep. Stuff. So give me your paper. Yeah, you can grab it. I'll mark the same as I've got marked, and you can watch the video afterwards and see where you were. Yeah, go for it. Right, this question. Write down the similarity postulate that proves the triangles are similar. Well, in this case, right, basically we've got a small triangle and a big triangle. They share that angle. That one's up there. This angle is the same as that one. Okay? And then this angle is the same as that one. So the postulate is angle, angle, angle. Okay? It's not side, side, side because that's congruency. You don't have similar triangles. Well, they are similar if they're congruent, but if it's side, 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 you're basically saying all three sides are the same. Right? Which is, it's not, it's the, we know the three angles are the same. Then if you were thinking about things carefully, you'd have gone, oh, that's 8. This side is?
16.
No. 24.
Oh.
This bit's only 16.
Oh, I thought that meant the
No.
whole side.
B to D is 8. D to A is 16. If they wanted the whole thing to be 16, the 16 would have been written. Yeah? Several people made that mistake. Therefore, it's multiplied by 3. Therefore, x to 18 gets multiplied by 3. Therefore, x must be 6. Okay.
Yay.
Yeah? Do I need to correct their work there? Or?
I did it.
Did you get?
Yeah.
Good job.
I got
Right.
it wrong.
Find the value of the measure. Alright. Did like when I saw people doing their SARCATOA, started seeing some people not bothering. Coincidentally enough, they're people that were making mistakes. Theta opposite adjacent hypotenuse. It is super important that you get them the right way round. Theta is 53. 45 is next to the angle. Part of the angle. Therefore, the adjacent is 45 and K is the hypotenuse. No O needed. So we've got cos of 53 equals adjacent over hypotenuse 45 over K. Okay, so if you remember the process, basically we multiply through by K. You don't have to write all of this, I'm just doing it for those people that forgot and just remember the switching thing and get it wrong. I then divide by the cos of 53 and get K is equal to 45 divided by the cos of 53. One person had cos of all sorts going on in a bracket. Don't know why, I've never said that, I didn't do it, I haven't shown you that, don't know who said it, don't know why, but someone did it. Alright? So if we work that out, we get K is equal to 74.77, round it if you like, 74.8. Okay. B. Go through the same process. SARCATOA does start getting a bit like, do I really need to? But
You do.
Make mistakes, don't make mistakes. Theta is x, right? I haven't said highlight the angle. The one that you highlight must be the adjacent side. X, this is the hypotenuse. We don't have that and don't want it. The opposite side is the 28, and at least one person has still got those the wrong way round. Therefore, everything was messed up for them, even though the rest of the method was fine. Getting those two wrong. You saw, don't you? You get what looks like a correct answer, but is wrong. Right? So in this case, no hypotenuse, so we're going to use the tangent of x equals 28 over 18. So this is like one of those early questions where x is the inverse tan of 28 over 18, and we get x is equal to 57.26 or 57.3, or whatever you want to do. Okay? Any questions?
No.
Find the distance. Now for this question, you don't need to use the grid. I just put it there for those people that like to do that. Me, I'm quite visual, so I use the grid. So I basically looked at it and went, well, if I just had, imagine I had a grid here. This one would be at -6, 2. So I'm going to put that over here. It's -6 and 2. This one is at 4. Right, so I'm not even doing a grid, but 4, but -9. So it's actually going to be down there somewhere. All right, makes sense what I've just done there. And then I'm going to go, well, -6 for that one, and this one's at 4. All right, this one's at 2, but this one's at -9. So if I draw my line like that, basically we've then got our triangle, right?
Yeah.
Which is a right angled triangle, and I know this distance from -6 to 4 therefore is 10, and from 2 to -9 is
7. Oh, wait,
11. Yeah.
Sorry, I'm smoking.
If you need to do a proper grid, do a proper grid. If you could just use the formula, some people use the formula and it's fine. But now we can just use Pythagoras Formula to find x. So 10 squared plus 11 squared equals x squared. So that's 100 plus 121 square rooted. Okay, so that's the square root of 221, and that comes out as 14.866 or 14.9.
Button.
Okay? If you just use the formula, the distance formula, I think, do we remember that the distance formula was it x?
x2
Yeah.
minus
x2 minus x1
squared.
squared
y2
plus
y2
y2 minus y1 squared square rooted. So you can use that formula and just decide that, you know, these numbers, this is x1, this is x2, this is y1, this is y2. You can just chuck your numbers in there, you're absolutely fine. I do it like this because I just turn to visuals. That's where I'm most comfortable knowing that I'm correct and seeing that. So if I just use the formula, for instance, I might make a mistake with negative numbers or something like that, and I can't visually see it. I'd have to really check, but up to you. So a few people used the formula perfectly successfully, didn't have a diagram or anything. That's absolutely fine. Okay? But you do have to have the same number. You can't use the other method and get a different answer. That's Sammy looks like he's
yeah, I added.
yeah. Okay. Starting to get to some the more tricky stuff now, yeah?
I didn't enjoy these questions.
I enjoyed the part 6. I didn't enjoy the part.
I
So,
didn't enjoy them.
We've got, again, I'll draw a diagram, because that makes me realise what's going on.
I think the other way around.
Fine, this is a right angle, this is the porch, imagine that's the porch, this is the ground, so that's 1 meter, all right, and the angle is 4.8 degrees. Find how long the slope of the ramp will be, so that's my x. So I look at that, I've got a right angle triangle, I've got an angle, I must use SOHCAHTOA. So let's use SOHCAHTOA. Opposite adjacent, oh sorry, theta opposite adjacent hypotenuse. Theta is 4.8. The opposite side is 1. The adjacent I don't know at the moment, I don't care. The hypotenuse is what I want to know. So it's not TOA. Alright, so I'm going to use the sine of 4.8 is equal to opposite over, so 1 over x. So by this stage, we might be happy to go, well, now I'm just going to swap. So x is equal to 1 over the sine of 4.8, which means x is equal to 11.95. Okay? Not rounding that at the moment. Even if I did round it to like 12 or something, because I listened to Mr. Potts and I wrote down the unrounded answer, after I do the second bit, I'm going to realise why. Find the horizontal distance between the porch and stuff. So basically, we've got the same situation. All right. This is 1, and I know this is 11.95, and now this is the value I want to know.
So it's went down.
This is 4.8. Well, I've got all sorts of options now. This is the example I told you about, where if I use trigonometry, I've got lots of options. I could also use Pythagoras Theorem. Great. Which one do I choose?
Not Pythagoras.
What I can use any of them, but which one did I say? My exam tip was to avoid using the answer that I came up with. Because let's just say I made a mistake or I rounded incorrectly. That will impact my part B. So I'm going to look at my diagram and go, all right, let's see if I can manage without my answer. And I can. All right, so I can do SOHCAHTOA again. And you'll see why in this question that thought process is important. All right, so theta opposite adjacent hypotenuse. Theta is still 4.8. Opposite is still 1. Now the adjacent is y, and I'm not going to use the hypotenuse. All right. So you could have written equals, and then you're like, well, which one do I use? Well, you could have used any of them. But I'm going to cross that one out, so I'm not going to use hype. So this time I'm going to use tan. So the tangent of 4.8 equals opposite over adjacent is 1 over y. So again, it's another y equals 1 over tan of 4.8. Right, and we get y is 11.91. So do you see why it's important that I didn't necessarily round?
Yep.
Why?
Because that would have changed
Well, if I did Pythagoras' theorem with a rounded number, this number would have been slightly up. Now the problem is, and I did see this in a couple of times, and they didn't comment on their answer. A couple of people had the same answer for the two numbers and didn't think that's a problem. Why is this a problem?
because the hypotenuse should be the longest side.
Yes. The hypotenuse must be longer than both of the other sides. It must be. So if you gave me the same answer, whether that's through rounding or mistake for A and B, there's a problem with your knowledge and understanding, which is criterion A, even if you got all the questions correct, right? If you didn't spot, but if the slope is the same length as the horizontal, I don't actually have a slope. There's a problem. So this question, I believe, is designed at such a small angle, because it's just a ramp, but your mathematics, your numbers, where rounding and the accuracy of your answers really does come into play and can make. Because if you went and here's the dimensions of the ramp I want you to build, Mr. Woodman, and he looks at you and goes, well, you're a bit of an idiot, aren't you? Why am I an idiot, Mr. Woodman? Well, because you just want me to give you 2 planks of wood that are the same length. Oh. Yeah? So you've got to be aware of that. So these two, they're very close, but if I rounded it incorrectly, and let's say I said that was 12, you know, you get this rounded to 12 as well, it's not going to work. Yes, David?
What city's building regulations state that your ramp has to be 4.8 degrees?
I don't know.
Because the slope of the ramp is 12 meters.
Right?
That's a lot.
Have you tried pushing yourself up a ramp in a wheelchair?
No.
Well done. What would you like the ramp to be like?
Very steep.
Really? Okay.
Yeah, like that.
David, I've seen you struggle walking up the stairs. Let alone having to push yourself up something like steep. So, you know, the effort level is required. So you will actually, you know, you can see it when you go out to build. These ramps are not just randomly put in place. There is a design for the amount of like height that is gained over a certain distance. And if it's too steep, it's unfair on people trying to get up. Think about trying to push up buggies and heavy babies and things in. You know,
Or bikes. Or bikes.
yeah. I mean, you shouldn't be riding your bikes into a building.
No, I mean like
that.
getting off and walking.
Yeah. You know, sometimes there's that one on the railway trail near that sort of bridge, isn't there, in Somerset, whatever, that it's got a little metal track, or used to, up the steps. And you're like on it, but you're pushing your bike like up a mountain, it feels like. So it's having a ramp like you might think 12 meters, but how long is 12 meters?
So it's 12 meters.
Yeah, it's probably, it might be a bit of an overkill, but in this case, but it's what it is. All right. The question that I don't think yet anyone got the final part of it.
I didn't get time.
I got
I
A.
lost time.
All right. It says label the triangles that are similar. So really, remember I kind of said to you, this kind of does meet, or it should do. So the triangles we're looking for, we've got A, B, C. We can do this around D and E, I guess. Right. So A, B, and E. Right. And A, C, and D are similar triangles.
Yeah.
Alright, so label the triangles, write down the triangles that are similar, indicate the similarity postulate. Again, it's just, well, that angle is it. It's the same diagram again, isn't it, as the other one. So it's A, A, A. A couple of people put AA. Hopefully you're not going to AA yet in your life, and hopefully you never will have to.
What is
Alcoholics Anonymous. If you're in the UK, I could say you're just getting your car fixed by the AA, but you know. But it must be 3, right? 3 A's, not just A. 2 angles. Well, you basically, if you know 2 angles, you know the third one. All right. So that's the similarity postulate we're using. And we've labelled the triangles. I don't think anyone got that completely. It says on average the Earth is there, blah, 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 lots of numbers, they're already there. Use this information to determine why the moon covers now. To be honest, it's not the easiest, but it's a 7-8 question, isn't it? That's why, and basically, if we look at the diagram, and I'm going to take it like this. I'm just going to take half the diagram, take that top half.
Yeah.
Alright? That's all I really need to show. So basically, here is the spot on the Earth that we're saying will be blocked. Alright? It won't be the entire Earth, you know that. Let's say this is the distance to the moon. Alright? So what was the height of the moon?
3,000.
So if we divide that by 2 to only get half of it, we get 1738. Okay?
1738.
And then the other is the diameter of the sun, which is 1.4 million. So half of that is only 700,000 kilometers. If we look at it, if we were to calculate this angle for both of the triangles, so let's do the Earth to the Moon triangle, right? The angle that we work out actually ends up being 0.52 degrees. If we do the entire thing as a separate triangle, so we've said they're similar, but if we actually do this, we get 0.53 degrees. Alright, explain to me the consequences of those two numbers being just that slightly bit different.
There's 150 million kilometers between them, so it makes a big difference.
It's not about the distance between them. Look, what's actually happening is if you take this line is only at 0.52, if I exaggerate it, right, if I get rid of that line, what's actually happening is, if I look, it's slightly above, yeah, that distance. So what's it going to do? It's pretty much going to block out
Almost
all the sun, but not quite all of it. Right? There's a 1/100th of a degree that is going to let a bit, and you know a solar eclipse is not a complete block out. There's that ring around it, yeah? So there is the fraction, the smallest fraction. Now, 0.01 of a degree in stellar distances from the moon or whatever, well, that's a huge distance of sun that you should still, you know, if you actually look at the actual amount of distance. So they're looking, so this question was real, that kind of reasoning, and going, well, what should I, there are other ways that you could try and work it out, but that's the one that they used in their answers. Does that make sense? Even if you don't think, well, that's, I wouldn't have thought to do that, but that's the difference. That's what a 7 and 8 question is like. You've got to take that step and think, oh, what knowledge do I have that I could apply? But it actually has to answer the question. You can't just say, oh, because there's so much distance between them that does it. It's basically like the first question, which is, well, it proves Pythagoras' theorem because this is Pythagoras' theorem. You know, you've got to actually answer the question. So you're all happy with that?